excuse me, obviously my voice does not normally sound like this, but I'm pretty sure it's things most known as program coordinator for the Iowa Water Center. We are the coordinators for the Iowa Water Conference. I'm really, really excited about this session this year. Most years on evaluations, we get responses back to say, where are the producers, where are the farmers, why aren't they coming to the Iowa Water Conference? My husband and I, we farm up in Hardin County. We have a farming in operation up there. And when I think of water management, when I think of who is impacted in water management, more than anyone else in the state, it's obviously going to be your producers because you're thinking about it day in and day out. You're thinking about it from so many different aspects. So I'm really, really pleased that we can offer this conference, this part of the conference this year. I'm going to talk a little bit about how the afternoon is going to go. We said the producer seminar is going to run from 1 to 4. We're going to be in this room from 1 to 2. We're going to start off with Adam Kiel from Iowa Soybean. He's going to talk to us a little bit about tile monitoring. I think I probably promised everybody that you'd get some nitrate test strips to take back with you. They did not come to me on time, so I'm going to be taking your information and going to be mailing those out to you as soon as they come. So please, please, please see me because I want to give these tools to you so you can take them home and use them on your farm. So from 1 to 2, we're going to be in here, we're going to be talking about tile monitoring, we're going to be talking a little bit, we're going to have a little bit of a roundtable discussion, talking about conservation, how that works for us on our farms, and what are different things we can do, what are our needs as producers, what are our needs in the state. So I'm also probably going to make everything for a little bit. You can come to the table. I brought the tables already, you're okay. We sit in the very back seat. I'm going to make you come up here so we can have this conversation. But you don't have to be here for an hour, right? And then you can, from 2:05 to 2:45, we have a bit of a long break. That's our opportunity. You can either continue the conversation with each other, you can talk to some of the people that you met, you can go out and that's our opportunity to look at the research posters. There's a lot of great water quality projects that are going on in the watersheds in the state. There's also some research projects that some students have brought posters for, and they're going to be judging based on those. So, Jared.
Where is this session after the break?
This session, I'm getting there. You're jumping ahead of me. We're only to 2:45. Okay, so 2:45, you have two options. This session can either go, we originally were going to have you all come back in 1 room again. But when I looked at the other two sessions that were on the schedule, I realized I didn't want to keep you from going to those if you wanted to. One of them, he was here this morning to hear Chris Anderson's plenary discussion on the capturing the drainage water for irrigation. Okay, he's going to have a discussion group on that at 2:45, and that's going to run for an hour. So 2:45 to 3:50. That's an opportunity to go in there to learn a little bit more about that, to tell them what you think the obstacles are, to tell them what you think, what processes need to be in place in order for you to make that work on your farm. So that's an opportunity to talk to Chris about that because that's a project he really wants to make happen. And in order to do that, he needs people that are willing to put that on their land and try it out and make testimonies for that. The other option you have is the 2:45 session, which is going to be next door, 250 to 252. And that is farmer perspectives on ecosystem service management and targeted conservation. So that's looking at the conservation framework put together by Bartram et al. Talking about how do we pick the best places on our farm for conservation practices. How do we make this the most cost-effective management practices for my farm, for my decisions? So they did a little bit of research. Looking at using that system approach. It's from the sociology department at Iowa State. So that's going to be going on to 250. And then again at 320, which is the next, you can either stay kind of in that data, in that research, in that mode, and you can discuss ceremony from D2 research with the Nature Conservancy did a project where they did some findings on soil health management and soil testing adoption with Iowa farmers, and that's also talking more about kind of the who's doing what and why are they doing it and why are they not doing it. So that's the 320 to 350. Or at that time also, you have the opportunity if you wanted to go to that 2:45 session. on firm perspectives on ecosystem service management. You can either go there, and these are all listed in your program as well. So you can either go there, you can go to Chris Anderson, or you can go to Chris Anderson at that 3:15 time. So at 4 p.m., we do have some sessions, or we set up the farm program ended at 4 p.m. So if you need to get home, we understand. The whole idea of having this on one day, specifically on one day, was because we understand that there are challenges when you're farming to getting somewhere, staying overnight, having to do things the next day. You've got to get up and shore, you've got to take care of your family, you've got to do those things. That may be personally working a 9-to-5 job doesn't necessarily have to take care of. So we wanted you to have the opportunity to just come here for one day and go home, but you're certainly welcome to stay for the conference. And I know you'll go through the rest of the conference program and maybe you'll find some sessions that would be interesting to you. Does anybody have any questions? Okay, with that, we'll go ahead and get Tom on with that. Thank you.
Okay, this suddenly makes a squealing sound. I apologize. I don't know how far I can go here, but I'm Adam Kiel with the Iowa Soybean Association. I'm the State Water Resources Manager for ISA. And I'm going to give a presentation that I gave at the Iowa Soybean Association Research Conference a couple weeks ago about our tile monitoring results that we've conducted those sampling tile lines in 2014. And I'm going to apologize ahead of time. We had a map here, and my presentation was built in a PC, so some of the figures aren't going to look exactly right, but I think I can explain them. So I'm going to go through this. If you have any questions at any point in time, feel free to ask, and we'll go address the questions that way. Just an outline of the presentation. I'm going to talk briefly about the projects that we're doing some of this monitoring for, talk about our program and the process that we go through to do the monitoring, and then talk about some of the results from a nitrogen and phosphorus standpoint, talk about some examples of improvement that we've seen in year one, and then just highlight some conclusions and closing comments about comments that we've got from farmers that participated in the program this year and some of their observations. So most of the monitoring that we conducted this year was through the Water Quality Initiative. And for those of you that aren't familiar with the Water Quality Initiative, it's 13 current projects across the state that demonstrate the practices and approaches outlined in the nutrient reduction strategy. There'll be more projects coming online, but those are the 13 that are currently across the state. The goal there is to increase awareness of the nutrient reduction strategy and act as those regional and local hubs for practice implementation, where farmers and producers can come, observe those practices, and take that knowledge back to their own farms. Many of those projects are doing monitoring of different forms. Some are doing water sampling through ISA, some are doing water sampling through other programs. Many are looking at agronomics and soil benefits of practices such as cover crops and other measures such as that. And nearly all are looking at the social impacts of these projects, how beliefs have changed, how many practices are actually implemented. So those are the different monitoring aspects that are going on. We're going to talk specifically about monitoring with these projects that are outlined here in the red. But I will mention that at ISA and through Agriculture's Clean Water Alliance, we are doing additional monitoring across the state for farmers. And that data is also incorporated in the slides that I'm going to show. So we've got data from the Water Quality Initiative, but we also have data from farmers that are participating through other programs as well. And those producers are spread more widely across the state than just these targeted watersheds that I'm going to talk about here. So our process for monitoring, we have a certified lab at ISA, and Chris Jones is our chemist on staff and runs all the analysis of our samples. But we do have staff that go out and collect the samples from tile lines, bring them back to our lab at ISA, and those samples are analyzed. The lab is fully certified by the DNR for analyzing drinking water samples, so our results are fully credible. All the results that we house at ISA are stored in a secure database that we have on site that links the results to the farmers' names, to additional information that we collect that I'll talk about in the next slide. And then once the samples are analyzed, we do send out monthly reports to those farmers that participate. It looks something like that you can barely see in the lower right, but it's basically just the raw data that we observe from that site, nitrogen, phosphorus, throughout the year. At the end of the year, we spend quite a bit more time compiling all the data, aggregating data, looking at trends, looking at different management practices and how they may impact water quality. And they'll get a year-end report that is more in-depth, looking at their samples, how they compare to many others across the state, and also how their samples compare to other management practices that might be occurring. Yeah.
Are you using a calendar year to year, or are you using like October?
Right, so last year we started most of our monitoring in April, and typically we'd wrap up, early fall, September, October. But this year we were monitoring clear into December. It kind of just depends on how much water is flowing throughout the year. But we try to get started in that late March, early April period and just monitor as long as we can. So in addition to that water quality data that we're collecting, we're also asking farmers to provide information about their management. So, and information about the tile system as well. So how big is that tile system? What's the drainage area? How old is that tile? How big is the tile? Those are all questions that we ask of participants so we can start to aggregate this water quality data with the field characteristics and management characteristics of that field. In addition to that, we're also asking the crop type, asking nutrient application rates and timing, things like that. Also, if they applied manure, what form all these things are in. Those are all questions we ask that are tied in to the data in the site in our database that we have on site at ISA. Also, very importantly, we ask if they're doing any conservation practices like cover crops or drainage water management. Obviously, some of that stuff is very visible when you get to the site, but some of the in-field management things may not be that visible to us. Using inhibitors, again, the cover crops may or may not be visible at the time we're out there. So those are all things we're asking that we can start to combine all this data together and come to some good conclusions about water quality coming out of these tiles. So if we look at our results from 2014, we had 153 participants this year, and we have over 1,200 samples that were collected and analyzed. Now, not all of those were from tile lines. We do have some reference sites that those tiles might dump into, like a stream or a ditch that we also collect water from. But we did have close to 800 samples just from tiles. And I should mention there was also times where we would go visit a tile and it was not flowing. We collected information at that point in time too. So our data set is much larger than just what's analyzed. We have this larger data set that includes times where we were there and there was no water flowing. So of those 153 sites, 92 sites had over 5 samples. And that's the kind of the data that I'm going to talk about here. Some of those sites that had 1 or 2 samples, we may not have included those in our analysis. We also didn't mention this, but we do a member monitoring program as well, where a member can mail in a sample to us. Those kind of bring in some quality control issues because we don't know how exactly the sample was collected, how long it took the mail to get there, if it was at the right temperature. So some of those samples are tossed out. We do have these 92 sites that are kind of in this data set that I'm going to talk about here.
Of the 153, how many producers?
Oh, sure. So we probably have just over 100 farmers participating in this. Yeah, some farmers have multiple sites, some just have 1 or 2 sites. So probably looking at about 100. And some warnings here with the data, of course. This is just 1 year of data. Drawing conclusions from just 1 year of data can be challenging. Detecting change is difficult, especially with changes in management practices. But detecting change from some of these treatment practices like wetlands, bioreactors, and ponds can be pretty easy, and I'm going to talk about that in a little bit. We're only looking at concentration data for the most of these sites. There are some sites where we do have flow information, but we're going to make a really big effort this year to ramp up collecting information about how much water is coming out of those tiles so that we can provide information about the load that comes out of these tiles, the pounds per acre, which everybody is curious about. That's a component that we're going to really try really hard this year to capture that and provide that to farmers that are participating. And we monitor only for the dissolved form of phosphorus. We heard this morning quite a bit about phosphorus in western Lake Erie. The data you're going to see is focused on that dissolved form of phosphorus that she talked about in her presentation. That's the most common form that comes through tiles, so it makes sense that that's what we're looking at here. And this is one of the figures that we present to participating farmers. So, and I'm going to warn you, this got a little messed up with the MAC system here, but I think we can make do. So, along the lower axis here, we've got the date of the year, starting around April 2nd or April 1st there, and going clear through the first part of December here on the far right. And then we have the dissolved phosphorus level. And each dot represents one sample result from one tile. So you can see how those results vary throughout the year. We do have a detection limit in our lab of about that 0.1 level. And that's kind of that lower line that you see there where no dots are below that point. So you kind of see here, we did have 2/3 of our samples at or below that detection limit for this year. And when we talk about levels that we shoot for, we think it's maybe these high samples. It's above the 0.5, which are of high priority to address right now. So you can see there how many samples fall in that priority box, if you will. But there are significant numbers that fall below that. And this next way of looking at the data kind of gives you an indication of how the samples pan out. So this is a histogram of those results. So you can see that detection limit is this 0.1 level and below. And then here broken down into categories of those sample results. So we did have 119 samples that were kind of above that ideal mark and would be of priority, and about equates to about 15% of the total samples are in that range where we probably want to do something about. So I'm not going to focus a lot on the phosphorus results. Obviously, it was a big focus of discussion this morning. We do have data, we're looking more into it. Once we have some more load information, I think some of this data will be more valuable. But I'm going to focus more on the nitrate results, because obviously that's been in the news quite a bit, and we're all aware of nitrate levels in the rivers and streams. So again, this graph shows those individual sample results throughout the year from April through December, and you can see how things peaked and are kind of tailing off towards the end of the year. But on this graph, we've got those 1,200 or so sample results. Take that back. This is around that 800 or 900 mark for just the tiles. There's no stream data in here. This is just tile results. So if we think about this in context of where drinking water suppliers are shooting for, they need to provide water to their customers below that 10 parts per million or milligrams per liter. It's the same measure mark. And that's what we see here with this green box, is those samples that fall below that 10 milligrams per liter mark. And then at ISA, we believe that if we get tile results around that 20 milligram per liter mark, that would do wonders for drinking water quality and nutrient reduction. We think about soil nitrate concentrations. When we take those in the spring, we shoot for around that 20 milligram per liter in our soils to have adequate nitrogen there for production. We feel the tile water coming out of that field should be about that same level, around that 20 milligrams per liter, to have good water quality and still have adequate nutrients in the soil for production. So It's our belief that if we target those tiles that are above that 20 milligram per liter mark, that's where we're going to have the most benefit. We can see here how that breaks down in the red box, with those samples in that red box being above that 20 milligram per liter mark. And if we look at a histogram here of those results, you can see 31% of the samples, and again, I apologize for the graphics being slightly messed up, but 31% of our samples are above that 21 or 20 milligram per liter mark. So again, those are areas where we think we would have the most benefit if we target conservation to those fields and to those tile outlets. But if you also look at it, we also have quite a few samples that are in that low range, that 10 milligrams per liter or below. So this is not a bad story. There's some really good examples of tiles that have really low nitrates as well. And all of these fields are draining agricultural fields. So there's no grassland or any other land uses in here. This is all agricultural uses that we have this data for. So this is a really interesting slide, and not all a bad story. There's some good examples in here as well. And a couple other ways to look at the data, and this graph didn't exactly come out exactly how I had it on my machine, but this shows the average, the high, and the low results for each individual tile throughout the year. So each black dot you see is one tile. And when we share these results with producers, we'll include a note as to which tile is theirs. So if you're a participating farmer, you would be shown that this site right here might be you, and this is your average, and this is your low sample result, and this is your high. So you can see the range of results here from each individual tile in comparison to the average. We've got some results up here that are in that red category again, that above 20, which are the priority, which we think, again, like I mentioned, would be the target of some good conservation practices. But there are quite a few where you have an average level that is below that 20 milligrams per liter mark. Those are places where maybe an edge of field practice might be more suited for reducing nitrates. Up here, it's probably a combination of in-field and edge of field practices that are probably going to be needed to achieve our water quality goals. Our goal is not to take all the nutrients out of the water because we know that we want nutrients in our soil to have viable crop production, but we do want to reduce the water quality impacts of that tile water.
Did you look at any reasons why flooding occurs right and such in variability, but there was a couple of variability?
Yeah, that's really interesting, and that's one thing we're going to take a closer look at is why is there so much variability? Some of these tiles do have surface intakes associated with them, so you could have some surface water coming in at certain times of the year where you might be diluting the nitrate. And that, I think, is one of those cases where you do have that surface influence, and it might have been one point in time where we had some surface water diluting that water, and we happened to be there and collect that sample. But normally it would be high on the high end of things. Sure.
A couple of questions. First of all, how many of these tiles, I'm probably a good question for you, but how many of these tile lines that you sampled dumped or emptied into a body of water, like a stream or a creek, lake, whatever else? And secondly, taking this sample, having done some of this in a couple of watersheds, taking a sample of the tile in terms of the nitrate concentration example, then taking a sample out of the stream to see what the dilution factor would be over there. I'm kind of curious, did you all explore any of that, or is that in the offerings, etc.? Because I would tend to think that would be a truer evaluatory process in terms of determining the impact of the nitrate going out into a body of water would be what happens in terms of dilution. I know it's there, but the dilution factor obviously plays an important role.
Yep. So the first question was about where do the tiles outlet, and most of them outlet into a stream. Some of them might have outlet into a road ditch, which then flowed a short distance to a stream, but For the most part, they did outlet directly to the stream. And to go back to your second question about this receiving stream and dilution as it goes downstream, yeah, that's kind of why we don't feel like we need to get down to 10 milligrams per liter with the tiles to achieve downstream water quality benefit. If we can bring these high results down to 20, that's a point where we think we could have a productive ag system, but also have good water quality for drinking water sources downstream because of that in-stream denitrification that occurs that we strive for. I think 20 milligrams is probably that good. Mike?
Do you have a feel on for any, as far as acres these tile lines drain on an average?
Yeah, so we're trying to select sites that only drain one management situation or one management scheme. We're not looking for corn, soybeans in one system. So we're targeting the smaller drainage areas. These might be draining 40 acres, probably on average, but they're mostly going to all have one cropping system in them. That's the way we should for it, because we're looking to provide really valuable data to the farmer. We want them to be able to use this data, and if we have a mix of till and no-till and corn and soybeans, that kind of takes some of the value out of the data. So I'm going to take a little closer look at some of these differences in the data. The first thing is just looking at regional differences across the state. And again, some of this stuff is already well documented in the literature, but again, having this confirmed in actual on-farm data coming from tile lines was valuable for these farmers that participated. So looking at regional differences here, both the Des Moines lobe and the Iowa surface, we saw those nitrate levels around 18.5 or 18.6 milligrams per liter. But in southern Iowa, we saw levels that were, around that 10 and a half level. We kind of expected this. Those well-drained, highly organic soils of northern Iowa tend to have higher nitrate levels. So again, this is nothing new for anybody, but again, it's confirmation of just using this data from actual tile lines to reinforce it. This is where it gets a little more interesting, is looking at variations in crop. So here we have the monthly nitrate average for both soybeans and corn. And you can see here in the table that we do have some differences. On average, soybeans are not quite 2 milligrams per liter higher in nitrates coming out of those tile lines that are draining soybean fields and corn. And then if you look closely at the August-September nitrate levels coming from corn fields, we do have a significant decrease there, likely due to higher ET during that point of the year. And I have another slide here that kind of shows this in graphical form, so you can see this throughout the year. So again, here this is statewide information, so it's not broken down by that's plant form region, but this does show those differences in the corn and soybean rotation. And the Iowa Soybean Association, we're kind of doing some additional research about this impact on land use and corn and soybean acres at a watershed scale, and we're working on publishing some papers highlighting these differences. So if we look at nitrate and phosphorus levels by tillage practice here, we can get a little bit more information. And this kind of reinforces some of the points that were made in the talk from this morning. If we look at this is comparing no-till, so strictly no-till, to any type of tillage, whether it be strip till, mulch till, conventional till. So anytime that you run a piece of tillage equipment through that field, it falls in this category on the right. So you can see our nitrate and our phosphorus levels are higher coming out of the tile lines under those no-till scenarios. You might have some head scratching going on here, but if you think about this increased water infiltration that we have under a no-till system, it's not promoting runoff like we would maybe have under a conventional tilled system. So we're getting more water flowing through that soil profile, getting down into the tile system. In turn, it's grabbing more of those nutrients and taking them out of the tile line as it flows. So again here, we're doing a great job probably of reducing our surface water impact as far as runoff and erosion. But just know that we might want to take a closer look at our tile discharge under that scenario and think about ways that we can incorporate practices to treat both the surface runoff and the water that's going through our soil profile and out the tile. And now just to get into some cases of improvement or noticeable differences, I guess that might be the appropriate one for this slide. So as producers, as some of you are, you're looking at your tile outlets and thinking about ways to monitor. If you just go and grab a sample from your tile throughout the year, it's informative. I mean, you know what's going on, but the power is being able to see how you compare to many others. And that's what this slide is showing. If we look at this slide, it just shows results from the Boone River watershed for this year. All the gray dots that you see are conventional. It's corn, soybeans, probably a tillage pass or two for those fields. The red dots that you see on the lower part of the figure is from a field that has cover crops and it's a no-till situation. And those nitrate results from that outlet were always the lowest of all the fields in the Boone River. So if this person was just monitoring his tiles, he would be able to see my numbers are low, but this figure showing his results in comparison to everybody else's is very informative to confirm that he's doing a really good job water quality-wise in improving things for his receiving stream and downstream. And just to put the averages on here, so the red line is the average of the farmer that's doing the cover crops and no-till, and that gray line or black line is the average of everyone else. So you can see quite a bit of difference there between the two scenarios. And Melissa mentioned maybe giving out the nitrate test strips, and that sounds like it's coming. You know, some practices lend themselves well to detecting change instantaneously, and a bioreactor is one of those. A trench of wood chips built that routes tile water through that, and through denitrification you have some cleaner water coming out the back end. You can go and monitor the water coming in and the water leaving, and you can detect that change right away. And this is one of those cases. This is a newly constructed bioreactor in southeast Iowa. The bioreactor was constructed in August, and right away you start seeing some significant denitrification occurring from that bioreactor. This gentleman invested a lot of his own money in this bioreactor and was very pleased to know that it was working as intended when he got these sample results back. I think it made him feel like his money was well spent, knowing that he was making a difference. Without this, I don't know that he'd feel the same way about spending $7,000 of his own dollars to put in a practice that he wasn't quite sure if it was working or not. So he was very pleased to see this and is excited, and now he wants to do more practices on other parts of his farm to improve water quality. I'm not saying that he wouldn't be doing those things without this data, but I think it confirmed that his money was well spent and he feels really good about it. And this is something that you could easily do with a nitrate test strip, is go and monitor that water coming in and water leaving. Another example that would be easy to monitor with a test strip is water coming in, water leaving, a pond situation. So in the red dots up there, we have tile water coming in to a pond, and those lower like purple squares is the water leaving the pond. So we can see here that there's at least a significant reduction in the concentration of nitrates leaving that pond than was coming in. So again, a feel-good story about a pond that we don't usually think of as a great nitrate treatment system, but at least the concentrations show that we've got better water coming out of the pond. And again, like I mentioned, this year we're going to try to get a better handle on the volume of water at these monitoring sites, and that might be more telling is if we're seeing true reduction in the amount of nitrates coming in and leaving than just looking simply at the concentrations. So some conclusions from 2014, looking at our nitrogen and phosphorus, got around 31% of our samples that are in that range where we want to take a closer look and maybe think about change in management or an additional conservation practice. 15% of our phosphorus samples were in that critical range. You can look at that both ways. 85% of them were maybe, in the range where we'd be okay. Water quality differences were very evident across Iowa and across different management practices. We saw that with the no-till versus the tillage, but also the changes in the Des Moines low versus southern Iowa. It's in some cases it's very easy to detect change and improvement. And we've also set a baseline now for people that change something to go forward next year or the year after with additional monitoring to detect that change and feel good about the changes they've made. So we've seen improvements and we are setting the baseline for future work. And lastly, the farmers that have participated have found this data to be very informative and in some cases very motivating. I'll send out a report, monthly report, and minutes later the phone will ring and it'll say, my samples are so high, what can I do about it? So, seeing how they compare to everyone else is very informative, very motivating, and I think through the monitoring that we've done and that others have done, I think this tile monitoring can be a great motivation for farmers, and when they see results, they're willing to share and show that what they've done actually is a really good thing for water quality. So we've heard really good responses from our monitoring program. I know it can be kind of controversial with exposing data that some see as sensitive, but as an ag organization, we can preserve that, keep these names confidential and present just the results in an aggregated format that allow for good discussions like this. So with that, maybe I'll wrap up and we can, Melissa can work on a discussion, but if there's any more questions, I can address those now.
Right towards the end here, you mentioned about maybe trying to do some just next year on measure
Well, we're going to take a pretty easy approach with a bucket and a stopwatch. Just see how long it takes to fill a certain bucket size, and that's a way to determine flow. Some of the sites that we have don't lend themselves to that method, but most do. So I think we're just going to take that extra effort to try to get that information gathered.
What's your sampling frequency, and do you do event sampling as well?
Yeah, so the tile monitoring, we just have a set schedule. We just go every 2 weeks to each site, whether or not it's been raining or not. But we do know that it's been raining or what the weather pattern has been in our sample notes. So we have that in the database as well.
As far as farmers being willing to share data with you guys relative to their management type practices, have you been successful with everybody being fairly cooperative in that? And have you been able to equate any type of management to some of the tile lines that you see that are higher levels of nitrogen and phosphorus versus others that are doing something different?
Yeah, so we haven't had any troubles getting the management data. When we enroll people at the start, before we do any work for them, we make it known that we would like to get that data so that we can help them understand their results in comparison to everybody else, looking at not just the water quality data, but the management data. So we're pretty upfront, knowing that we're going to be asking for that. So that hasn't been a problem. Yeah, I think that's a good thing. And I kind of forget your second question.
Have you been able to look at some of the management type of things you guys are doing versus the tile inlet, outlet? They might correlate certain things with the higher versus lower.
And that's a really tough question, and there's a lot of noise in the data. You think about some of those higher sample results that we've seen. One of those folks in particular is very, I wouldn't say frustrated, but he's getting to that point because he's been a long-term no-tiller. He's been doing cover crops for a couple years, but he's got some of the highest nitrate readings that we've seen, which can be a very frustrating situation to be put in. And we're trying to work through that with him. We suspect it might be a case where his soil is just performing at such a good clip that he's got a great organic matter base built up. He hasn't adjusted his rates ever, to account for that. So maybe that's something we could look at doing. But it sparked interesting conversations. I think we'll have more of those moving forward when we have more years of data. But those are kind of the early ones that we've had just looking at it this way. But I would say on the other end, on the low end, there's just as many or more people that have done a management practice that we think of for water quality, cover crops, some of those type of things. We see them more on the low end of things.
I'd like to steal a show.
Yeah, go for it.
I'm Vernon Reddick, and I'm a small farmer north of Bartram, Iowa. I came to Iowa from Colorado almost 60 years ago to be a product design engineer for John Deere. And I've been started farming. We bought a small farm and I started farming in 1969, so I've been gradually increasing a little bit, been farming for 46 years. And I'd like to share some of my thoughts on this nitrate thing. And I'm going to read a letter that I submitted to the Des Moines Register over a year ago. They didn't print it. So I'm gonna read it to you.
Can everybody hear, or is it you guys microphone, or? I just want to make sure everyone can hear. I can.
You okay?
Yeah, good, great. Go for it.
Okay. It's titled Nutrient Reduction. There seems to be a strong push to force farmers to reduce the amount of fertilizer being applied because of hypoxia and high nitrates in drinking water. By some estimates, up to 1/2 of the applied nitrogen is lost, most of it through leaching. Most of the problem, in my opinion, is improper application timing. When ammonia or ammoniacal nitrogen is applied, it adheres tightly to the soil. Depending on soil temperature, microbes convert the N to nitrate, which can then leach into the groundwater. When ammonia is applied in March or April, not to even mention fall, it can start to be converted in about 3 weeks. At that time, the corn plants are small and cannot utilize the nitrate. May and June are excess rain months, and much N is lost. For the last 40 years, I've been applying ammonia around the 1st of June. The conversion time takes place during the rapid growth stage and after excessive rains. And at that time, the corn plants are about this high and they can really suck it in. Nitrogen stabilizers, which kill the conversion microbes, are also currently being used. This is a step in the right direction, but not effective utilized. And I'll have to admit that's a personal opinion. And then I've got a chart here that was sent to me, Pioneer seed corn observation. And these are the approximate time for ammonia to convert to nitrate. Ammonium sulfate, 1 to 2 weeks. Anhydrous ammonia, 3 to 8 weeks. Urea, 1¼ to 2½ weeks. Ammonium nitrate, well, 25% in 1 to 2 weeks. 25% is nitrate, 0 weeks. UAN, which is urea ammonium nitrate, is liquid. It's converted to nitrates 50% in 1¼ to 2½ weeks, and 25% in 1 to 2 weeks, and 25% is nitrate, so it's ready to go, ready to leach. And so that's my opinions. I hope that, and I know I'm talking to a select group here, but I hope that it does some good. Thank you.
Any other questions for you?
Brandon's got a question with that.
I got 2 quick ones. Are you working with anybody right now monitoring folks that are participating with the on-farm network? Because I'm thinking it'd be really cool to be able to take a participant of that program, show them that they can get the same yields by using, say, 40 pounds less in per acre, and have a positive reduction on the amount of nitrate in the tile line as a result. My second question is, have you seen an influx or a great decrease in the number of people that want to participate next year based on the Des Moines Water Works issue with the lawsuit?
Yeah, so the first question was about incorporating monitoring with our on-farm network. And those of you that aren't familiar with Iowa Soybeans on-farm network, it's a base of farmers across Iowa that do replicated strip trials in their fields. And are we engaging those folks in a monitoring discussion? And the answer is not really. And the reason is, if they're applying different rates throughout their field, they're using different practices and replications across the field, it doesn't lend itself very well to a good monitoring scheme to detect that change that we're looking for.
Yeah, you might have to change the scope of the program a little bit to make that work. I didn't know if that was under consideration or if you could try to tie those two together to show a positive impact on water quality or not.
Yeah, we're working on new ideas like that that tie water quality to management. It's going to be a case-by-case basis whether or not it works out, but those that do, we're pushing the monitoring. And that kind of gets at your second question about interest and have we seen an uptick in interest. And I'd probably say a slight increase. And I don't know that it's necessarily those folks in the Des Moines or the Raccoon watershed, but statewide we're seeing an increase in interest. Especially in some of those watersheds where maybe they talk to their neighbor who's participated in the program and find out that it's not that scary, and they're interested in doing it this year. So the second year of some of these WQI projects, I think we're seeing quite an increase in monitoring interest.
I suppose it helps that you make sure that everything's secure and it's not public information and so on.
Yep.
How much the data set has surface intakes? Do you have a feel for if that's is a potential skew one way or the other in terms of the concentrations in the data set?
Yeah, there's not a lot. I pointed out one with that wide swing from the high to low nitrate. But on most of the sites, probably over 90% of the sites do not have surface intakes. I can get you the exact number, but that's roughly what we're looking at. Most are pattern tile without surface intakes. Well, thank you very much.
Quick poll in the audience. How many people here do you have that are active participants that are actually serving? Do you have part-time or full-time? Okay, so my question to you is, how many people are participating in tile monitoring or some sort of monitoring on their farm, and they're getting data for their farm? Okay, so we have a few. My question is, and Adam's a few questions for you as well. So if I'm not doing this monitoring, which we're not on our farm, but it's something that we're interested in, how would I get started? How would I even, where to begin? How would I know how often to test or what I'm testing for? What I'm looking for? What would I do with the data once I have it?
Yeah, so Steve, if you want to tackle there.
We've just tested one time on about, 20 different tile lines, and got some pretty good data back, but I don't feel that it means anything until I think you need to start a protocol. I mean, I think you just can't be haphazard. You gotta have an end game in mind. Once you start, I think you need to get on a system so at the end of the day, or at the end of the month, or year, or 5 years, you have something to report. I'm a little afraid if we're haphazard, and you just need to get a protocol, and if you have 3 people doing it, you might get 3 different answers, We do a lot of things in our farm. We do have tile intakes, we spread 3 different types of manures, on the surface, and that's a very big concern of mine, so that's why I really, really want to watch close what's happening. And I would say, and I'm not sure what the cost is, I'm not exactly sure what the cost value price is we recommend, but you need to take all that into account, I guess. And I would suspect, once you start with the lab, you want to stick with one lab, possibly, so you can take as many random events out, Those are just some of my thoughts, I guess.
Yeah, every farm and field is different. And in Steve's case, even though we took samples at one point in time, we took it from 20 different sites, so he can compare different fields, different soil types, different management practices to each other. And that's informative in itself. But most of the data that I talked about was on a set schedule. Like I mentioned, every 2 weeks we would go and visit that site. It's a pretty labor and time-intensive monitoring program, but it does provide some very useful data, if the situation allows.
Well, I'm very concerned. We're in a watershed district now, and a lot of people that attend our watershed quarterly meetings, they're just very concerned citizens, and they want to start testing the water themselves. And that got me a little concerned that we want to get a jump ahead of them and make sure we know exactly what's coming out, just so we can correct things. And we had some pretty good reports the first time, but I have a feeling, we're going to have some measurements we'll have to find corrections to be able to move. Just so we want to know first before somebody else finds out.
Adam, how close are the test strips compared with your lab samples? Look at it that way.
Yeah, I'm not entirely familiar with the ranges that you see on the test strips. Maybe Mary can address this, but they do come in ranges. It's 0 to 1, maybe.
1 to 5, and then there's 20 and 50. So, you're definitely going to see that upper range, and you're definitely going to see if it's, and they tend to run a little bit low on the low range. So if it's 5, it may be more like 7 or 8, actually. But we've done a lot of comparison testing with the eye-water nitrate test strips in the past. I get people that information if they're curious.
Mary, did you want to talk a little bit about that, about the eye-water monitoring?
Sure. For those of you who don't know me, I'm Mary Silbeck, and I coordinate the eye-water volunteer monitoring program for the Iowa DNR. What we do is we train citizens to do basic water chemistry and biology in a 8-hour workshop. You learn how to do some basic test strip, nitrate test strip testing, phosphorus. We do some chloride testing. We do transparency of water. We talk a little bit about sort of the basics of water quality. We talk about how to set up a monitoring plan, how to do flow or discharge measurements of streams and that kind of thing. We also have a database that people can either submit data to or not. It's really up to you as a citizen to decide whether you want to do that. And we replace equipment for free. So right now I'm sending out test strips like crazy, and people are getting ready to monitor because spring is just around the corner. And then we also train people how to do bacteria testing if they want, as well as looking at biology. So hopefully one of the goals is also to improve water quality so that we've got better critters living in our streams and our lakes, and train people how to do basic testing on that in different workshops. So I have about 5 workshops set up in the state right now. Cedar Rapids, Sac City, Des Moines, forgetting some. Our webpage has got all that, and we take requests for workshops. So one of the things we're trying to do is get more nitrate test strips in people's hands so that they can do the testing themselves, start to get comfortable with what the numbers are and how they will change through time. It's not a replacement for laboratory testing, but it is, I think, a nice augmenting to the laboratory testing that you could go out every day if you wanted to, if you had nothing else to do, to kind of fill in the picture. So I'm happy to talk to people outside of this if they're interested.
Yeah, absolutely. Well, you're here in a couple of minutes, and so you have an opportunity to talk to Adam, you have an opportunity to talk to Gary. If you want to talk to Steve, obviously, is that you're the only person doing it, but you obviously have some experience with it. If anybody's at lunch, you probably talk to a little bit more big operation anyway. So something that you mentioned, Steve, was talking about at the watershed level, about we're looking at the watershed level. So there's monitoring at your farm level, and then there's also taking the big picture of what the watershed level looks like. And one of the things that we talked about when we were talking about bringing together this workshop, and the kinds of things that we were interested in talking about were talking to your water quality initiative coordinator and talking to the people who are coordinating watershed efforts in the state. Jamie, I'm going to put you on the spot and see if you'd like to talk a little bit about that. You have a few minutes.
So I was writing notes. You wanted me to talk about what specifically, the water quality initiative, or?
Yeah, and just talk about if somebody wants to make more efforts to make coordinated efforts on their farm to, who do they talk to?
Sure.
Who would be a good place to start?
Right, well, I think a good place to start is your Soil and Water Conservation District office. They tend to be the group that is managing any existing watershed projects that are happening or are funded through various sources. Also, they're housed with NRCS, so between those two, they'll know whether there's a state, local, or federally funded effort that you can connect with. Also a good place to start with your commissioners, the Soil and Water Conservation District commissioners. If you have an interest in getting a group started, they're one group that can help you do that, and they will have a good sense of other farmers in the area, that there's interest starting to brew from others as well. So they can connect you together and help to put together a proposal and start the process for planning for that watershed project, for implementing if there's been a plan in place prior, and a good place to start. ISU Extension can always be that group for you as well. We lean more on the side of facilitating, connecting you with the right resources, gauging the interest of other farmers, and making sure that all the bases are covered and you're reaching out to the right groups and taking advantage of any resources available. And I know many of the ag groups, Iowa Corn, Iowa Soybean, others are all very much on the keeping track of all of those opportunities for farmers. So really, any group that you normally work with has a water quality connection and can get that group together for you.
Okay. Anybody have any questions for Jamie? Okay. All right. Well, with that, we're just about at the break here. There's a break, like I said, from 2 o'clock to 2:45. There'll be some sweets and coffee out. I think they're all going to be down on the register, level that you registered from. So you want to go down there and grab something. Posters are up here. If you'd like to continue conversation, if you'd like to have to talk to people, I encourage you to take this time and really talk to people and talk to folks. Sessions will begin again at 2:45. And if you have any questions for me, please let me know. And if you want nitrate test strips, please come to me and give me your address so I can download them. So I'll just sit here for a little while.
I'm higher than nitrate level.